All right, welcome to Unit 14, Day 1. For you guys online, the packet is posted. I will say be careful. Print out however much you want as we go, or work on your own paper, but we're going to switch some days in here later. So especially you guys at home keeping up, just be wary of that. I'll remember to say it when we get to those days. You guys here in class, not really a big deal because we'll keep up with it as we go. The trouble is this day 3 worksheet has cosine problems on it, and we haven't done cosines yet, so we'll switch those 2 days. Looking far ahead, this next week is a bunch of senior activity stuff, so some of the seniors won't be here for prom, picnic, depending on what period it is, and maybe that infamous senior skip day there. But we've kind of accounted for that. Area of triangles is pretty easy. Word problems is just practice. Review is practice. And then there's one more review day before we get to the test on April 21 and 22. So, long way away. But we've factored in the fact that the seniors may be checked out for a few days in there. We get it. We understand. And kind of working with you on that. Any questions on looking at the calendar for the next couple weeks? Today is easy. Law of signs is really easy. Ambiguous case is, I guess it's maybe obvious. Ambiguous, it's trickier, but we'll save that for tomorrow. It's a kind of a subset of law of signs. So we'll learn the equation today, learn how to use it, get used to it. And then tomorrow it's the same equation, but we got to really be careful when we use it tomorrow. So make sure you get today down. It's easy, but make sure you get it. That way when we add some twists and turns to it tomorrow, you'll be you're able to navigate that and be okay. All right, well, let's jump in then with law of signs. U14, Day 1. And we use law of signs to solve triangles. I guess it's mixed news, but up until now, you kind of had to limit yourself to right triangles because you had a squared plus b squared equals c squared and SOHCAHTOA, and you could solve any right triangle. Now we don't have to. It doesn't have to be a right triangle. It's for all triangles. So this is a little bit broader type of equation because I don't have to worry about if it's a right triangle or not. It works for everybody. So here's the formula. Formulas. You'll see why I phrase it that way in a minute. Sine of A over A right, probably should draw a picture first. So draw a triangle, any old triangle you want. Make the angles capital A, B, and C. So the angles are the capital letters. The sides are the lowercase letters, and they're across from the corresponding capital letter. Right? A is across from A, B is across from B, C is across from B, C. That seems simple, maybe, but if you get that mixed up, you're going to have a real tough time. So make sure your sides and angles are across from each other. All right, so sine of angle A over the side of A equals sine of B, sine of angle B over side B equals sine of angle C over side C. Now, I guess that looks a little bit weird because it's like a 3-sided equation, which we don't really use. So here's the deal. You you use 2 pieces at a time. And it kind of depends on what you know as to which pieces you use. And it's not hard to figure out, because if you don't know either of the A's, well then don't use anything with A, right? If you don't know either of the B's, well then don't use that part. And if you don't know anything about C, well then don't use that part. So only use 2 at a time, so people get confused if they don't hear that. They try to set it all up, and it's not wrong, it's just not really helpful. So pick out what you know and what you're looking for, and then pick the right 2 to use. Now, what I'm going to say next doesn't help yet, but we need to start thinking in these terms. Law of cosines versus law of sines, like when to use which one. And law of cosines is next week, but we need to start thinking now, like, how do I know which one to use? The good news is you can't really use the wrong one. If you try to use one that it's not right, then it won't even work. So it's not like you get a wrong answer. It's like it won't work at all. So it's not a huge deal. If you pick the wrong one, you'll figure it out pretty quick because you can't get an answer. But if you want to pick the right one from the get-go, see if you recognize these type of letters. Do those look familiar? Yes, I just heard the G word, geometry. Do you remember where you used those in geometry? Proofs, okay. And that's why everyone's like, oh, the proof thing. This isn't proofs. But, in fact, this is a really easy part of proofs, right? Because side, 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 angle, side, angle, angle, side. If this is the information you have, then this tells you which equation to use. So if you have side, side, side information, we'd use law of cosines. If you have side, angle, side information, law of cosines. Either of these, law of sines. Do you remember which I don't know how to word this, but you know the one I'm going to try to get to. The bad word one? Everyone's like, oh yeah, that one. The reason that wouldn't work in proofs, angle, side, side, but you can't write it that way because then it's a bad word. You can say it though, angle, side, side. It doesn't work in proofs, and that's the ambiguous case that we'll look at tomorrow. So it's ambiguous, which means we can't use it for proofs. So we'll get a little more insight on why you couldn't use this in geometry. In geometry, you probably just remembered, oh yeah, it's the bad word, we're not allowed to use that one. Tomorrow we'll see a little bit more why it doesn't work. But again, you don't have to remember this because, in short, basically you try to use law of sines because it's easier, and if you don't have the right information to use law of sines, then use law of cosines. Now, that's a little bit ahead of what we need because today is all law of sines, so you don't have to pick. You know it's going to be law of sines. And we'll sort of build up to it. So we do law of sines, ambiguous case, law of cosines, and then we'll mix them up and you'll have to figure out, well, which one do I need to use? So I'm trying to build in ahead of time how to pick which one, so that lesson will be a little easier when we get there. All right, let's use this thing. Example 1, angle B equals 31 degrees, angle C equals 20 degrees, and side C equals 210. And the directions will say something like, solve the triangle. Yep, solve the triangle. Now, I guess some people could start the equation and pick the right stuff just by this information, but most of us would be much better off to draw a picture. So draw a picture. It does not have to be to scale. It's really just to help you see who's across from who and help you see what do I know and what do I need to know. What am I missing? So just draw a random triangle. Label the angles however you like. But be careful, once you label the angles, that now sets who the sides are. Right? So once you label the angles, you can't randomly select the sides. A has to be across from A, B has to be across from B, C has to be across from C. All right, let's label what we know here. Angle C is 20 degrees. Angle B is 31 degrees. And side C is 210. All right, so which case is this? Of these, well, we know it's not an ambiguous case because that's tomorrow.
Good morning, Mustangs. At this time, all English 2 students should be...
So it's not an ambiguous case. It's not law of cosines because we haven't even done that yet. So is it ASA or AAS? Yeah, AAS, angle side. So we know it's law of sines, mainly because that's the only formula we know in this unit, but it's AAS. So therefore it's law of sines. Maybe an even easier way to pick law of sines is that if you have an angle side pair, if you know A and A, or B and B, or C and C, then it's law of sines. So if you've got C and C, that's another way to say it's law of sines. If you know two things across from each other, it's law of sines. Before we even get to law of sines, is there something we could find using our geometry knowledge? Like very basic geometry knowledge? We're trying to find everything that we don't know in that triangle.
The third angle.
The third angle. How can we find the third angle?
Add the other two and minus 180.
Yep, they all add to 180, so 180 minus the other two. So we still got to remember our basic stuff here. 180 minus 51 would be 129. You don't have to label the triangle. Some people like to label it, that way they kind of keep up with what they know and what they don't know to make sure they found everything. You don't have to, but it might be helpful. So I'll put the 129 on there. We said we knew the C information, so let's write that equation, or that piece of the equation. Sine of 20 over 210 equals, and now we kind of have a choice to make, because we need to find side A and side B. So we can't find them both at once, like that would be kind of cool if it worked that way. Let's just find side A. So we'll write the A equation. So sine of, or the A piece of the equation. Sine of 129 over A. Again, there's also sine of 31 over B, but I don't want to mess this up. Use them two at a time. If you wrote it equals sine 31 over B, it'd be a true statement, but there'd be no way to solve for anything. So use them two at a time. Now I need a calculator. Looking for a nice one, but I don't have a nice one up here. Well, do have a nice one after all. Well, I don't really need the calculator first. Let's move some things around here. So A sine 20 equals 210 sine 129. Right? Cross multiply. And then divide by sine 20. So 210 sine 129 divided by sine of 20. 210 sine 129. Careful with parentheses to make sure you're taking the sine of just 129 divided by sine of 20, although I better be careful. I need to be in degrees. Thank you. She's not here. It's a little bit weird because the checkout passed and she's not here. So she's already checked out. Where was I? Make sure I'm in degrees. Enter. So A, side A is 477.167. Let's see, that seems big, but look at my picture. My picture is not the scale. 129 should be a lot bigger, so side A should be a lot bigger than the other two sides. So that makes me feel a little bit better about that answer. The biggest angle is always across from the biggest side. The smallest angle is always across from the smallest side. So that makes a nice little check. It doesn't guarantee you got it right, but the big side should be across from the big angle. And again, you don't have to label the picture, but if it helps you keep up with what you know and what you're missing, then maybe it's a good idea. All right, I still need to find side B. So I need the B information. So sine of 31 over B equals, oh, this is good news now. I can equal it to the A stuff or the C stuff, right? Because I know everything. Which do you think would be the better choice to equal it to, the A stuff or the C stuff? Why the C stuff? You're right. That's right. That's exactly right. If you get A wrong, you don't want that error to continue to mess up your problem. So, or another way to say that is, I absolutely know what C is because it was given to me. So I'm going to set it equal to the C stuff. Oops. So sine of 20 over 210. You were going to get the same answer if you set it equal to the A stuff. It's just that in case you messed up the A thing, you don't want that mistake to carry through your problem. So why don't you test out your algebra skills and your calculator skills. I'm going to press pause. See if you can solve for B, and then we'll check in and see how we did. All right, so cross multiply, I think you have up with this. And then divide by sine 20 to get B by itself. And we get 316. Again, I'm done now, but if you want to make your sort of finish off your triangle, you can. It also is helpful to finish, when you finish, to make sure that your smallest side's across from the smallest angle, biggest side's across from the biggest angle. Again, that doesn't help you find anything, but it does give you a little confidence when you get to the end that you probably did it right. That would also might catch something if you messed up the degrees versus radian thing. You might catch it on that. I think everything today is in degrees, so if you've got your calculator right now and you put it in degrees, you're going to be fine for the worksheet. In fact, this whole unit is degrees, so you'll be good. Physics is degrees. So, yeah, if you put it in degrees right now, you're probably good for the next couple weeks anyway. All right, today's assignment is worksheet 1. I'll pass that out to you guys here in a minute. You guys online, it's posted with as part of the packet for this unit. It's 10 problems, pretty straightforward. Just law of sines, law of sines, law of sines. So a whole lot of cross multiplying and dividing to find the missing stuff.